In this lecture, we look at gravity. Gravity is a force that attracts objects to one another. Newton's law of gravity says that this force depends upon the masses and the separations of the object. The functional form of Newton's law of gravity is that the magnitude of the force is equal to a constant big G times the mass of one object times the mass of the second object divided by the square of the distance separating the two objects. That is, if we have a mass 1 and a mass 2 and a radial vector going from the center of one to the center of the other object, that's the r in the bottom of the Newton's law of gravity, then the F points from m1 towards m2, and there's also a force minus F that points in the opposite direction from m2 to m1, so the two are attracted to each other. G is the universal gravitational constant, and it has the value of 6.67 times 10 to the minus 11 newtons times meter squared divided by kilogram squared. Gravitational force acts as if all the mass of a sphere or spherical shell is at the center of that sphere. So if you're looking at the Earth and a person standing on the Earth, the separation between the person and the Earth is the radius of the Earth. So it's the distance from the center of the Earth to the person. As an example, let's look at the force of gravity on the surface of the Earth. The mass of the Earth is 5 times 0.98 times 10 to the 24th kilograms, and its radius is 6.37 times 10 to the 6 meters. So what is the magnitude of the force on an object with a mass of m on the surface of the Earth? Well, we can write down Newton's law of gravity, and we plug in the various constants and values. So we have those. And if we go ahead and use our calculator, we find that the magnitude of the force is 9.8 meters per second squared times m. So that is the acceleration of gravity on the surface of the Earth, and it's the g that you've become familiar with, the little g. What would be the acceleration of gravity at a distance of 10 Earth radii from the center of the Earth, so in a fairly distant orbit? Well, you take 9.83 meters per second squared and divide by 10 squared because you've increased the distance by 10. So it would be 0.098 meters per second squared. So if you go 10 Earth radii above the Earth, the force of gravity drops significantly by a factor of 100.